Okay, let's look at the how to find F inverse. Alright, in the previous video, we talked about how to kind of educationally guess the formula of the inverse function, but we need a more systematic method. So here's the method. Alright, so for example, let's say if you have f of x, which is x over x minus 3. Alright, so here's the first step. Alright, replace f of x by y. So we can easily do that. So it's y is equal to x over x minus 3. Right? Then step 2, solve this equation for x. Right? So first step would be I'm going to multiply both sides by x minus 3. Right? So that I can get rid of this denominator. So y times x is xy. Right? Y times negative 3 is negative 3y. Is equal to, right? So negative x minus 3 and x minus 3 cancel out. You just get x. Right? Then next move would be I'm going to put all the terms that has x on the left and everything else on the right. So this guy is x, so I'm going to put it on the left hand side. And a negative 3y doesn't have x. I'm going to put it on the other side. Right? We can do that by simply subtracting x, so that the x is going to be on this side, and adding 3y. Alright, so by subtracting x, we have so xy is already there, and you subtract x, right? So we took care of this guy. Alright, then this is equal to, alright, we add 3y, so we take care of that by adding 3y here. Alright, then we can factor out x from there. We'll get, right, so x is factored out. Then you have y from here. Alright, so maybe I should do this. So here, this x is factored out here. Also, this x is factored out there. Alright, so you have y minus factored out, so minus 1, which is equal to 3y. Right, the last step would be, since we want to isolate x, we have to divide through by quantity y minus 1. Right, so x is equal to 3y over y minus 1. Right, so we got that. And last step, third step would be switching, exchanging x and y. So when you see x, we put y, which is equal to, and you have a 3x over x minus 1. And the last step is replace y by f inverse of x. So therefore, f inverse of x is equal to 3x over x minus 1. Right? So this is the formula for the inverse of the given function. Right? The reason why I went through this systematic method is that for one thing, you can find the inverse function fairly easily, and also it clarifies what goes on when you go from original function to its inverse function. Right. So let's look at the graph of f and the f inverse. right? So here, so let's say this is a graph given, which is the graph of original function f, right? Then we want to find the we want to sketch the graph of the inverse function, right? Then let's pay attention to this step right here, right? First step, it really doesn't do anything, just the renaming things, so we're not really changing anything. And solving for x is just the rearranging terms, so we're not really changing anything, right? But look at step 3. Right, step 3, it's actually changing quite a bit. We're switching x and y, all right? And step 4 really doesn't do anything. This is renaming. So let's pay attention to step 3, right? Switching x and y is required to go from the original function to the inverse function, all right? So what happens to their graphs if you switch x and y, right? So here's the x-axis, and here's the y-axis. So if you switch x and y, x-axis becomes y-axis, right? And a y-axis becomes x-axis, right? So you can see that when you do that, you're basically kind of flipping about this line y equals x, 45-degree line. So this is y equals x, right? So if you're switching x and y, this graph is going to be reflected over to the other side of y equals x, right? So the graph is going to look like this. So I'll try my best to get the reflection going. So here, oh, actually, I have to do it again. Right, how about this? I'm gonna do it again. Hopefully I can do it better. So you have this. Alright, it's not the best, but it looks kind of like this. Right? So you can see that the graphs have symmetry. It's symmetric about the line y equals x. So the graph of f and g are symmetric about the line y equals x. Right? So if you know the graph of the original function, then you can easily sketch the graph of the inverse function without even knowing their formula. All you have to do is reflect the graph about the line y equals x. And this comes from the fact that we're basically switching x and y. All right, that's it. I hope that this was clear.